Okay, so going to the first question, it says, what is the density? Density is mass per unit volume. Okay, so mass over volume. Then it says this x, pyramid x, okay, height, okay. What is the absolute uncertainty in x? So you just do 4 times 5 over 100. .2. So just write to one significant, okay. 0.2 plus minus, right. Now, density P is calculated from measurement. Determine the percent uncertainty calculated in P. Oh, rho, sorry. First, we'll make it the subject, 3m. 3m over h x squared equals to rho. All right, so change in rho over rho equals to change in m over m plus change in h over h plus change in x over x and multiply by 2 because of the power. So m over m is just 2%. You don't need to do anything. Percentage is given. H is 4% and x is 2 times 5%. So that would be 2 plus 4 plus 10. That would be 16%. So here you go.
Sir,
Yes.
why don't you multiply by 2 in the first part?
Because the person, it just said percentage in x. It does not say how much does it contribute to the uncertainty of rho or the density. Do you understand what I'm saying?
Okay, so I just don't look at the formula for this.
Which form? No. If they
Okay.
say percentage or absolute for any one of these, that does not really, it just is this value. If
Okay.
they say in rho, then it has a contribution of 10%. Okay. All right, now the square base of pyramid rests on horizontal surface. Calculate the average pressure. Uncertainty is not required. They're nice people actually. So pressure is force over area. And what we got mass, we got x. So generally, whatever shape is there, the volume, right, is always base area times the height. So x into x times height. So it will be x squared h, right? And I don't know whether that's correct or not. Really don't know. But we don't need the volume, right? We just need, I think it's also half, but I don't know. It should be half, but anyway, we just need the area. So, or it's 1/3. I don't know the volume of pyramid. So area is x squared. Okay. So f over x squared. Now the problem is we have weight mg over x squared. Mass is 19.5 grams. 19.5 times, oopsie, 19.5 times 10 raised to minus 3. Because I changed it to kg, okay. 9.81 divided by x squared. Right. Do we have x? We do. 4 centimeters. 4 into 10 raised to power minus 2 whole square, because I changed it to meters. Come here. Okay. Then 19.5 times 10 power minus 3 times 9.81 divided by 4 into 10 raised to power minus 2 squared. So that's 119.5 It would be 120 then. Correct to two significant figures, okay? Make sure you always write the correct significant figures. Now, a person uses trolley to move staircases at an airport. The total mass of the trolley and the suitcase is 72 kg. Okay. 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 Calculate the power required to overcome resistive force when they move at constant speed. Power is force times velocity. This force is 18. And the velocity is 1.4. Pretty straightforward. That's 25 watt. Then time taken to trolley to come to rest after it is released. Oh, wow. I think we can do that. Calculate the time taken trolley to come to rest. So we got to see what do we have actually. This is something, you know. But how? First of all, we need SUVAT. The displacement is not given. Initial velocity is 1.4. Final is 0. Acceleration is not known. Time is not known. So we got to find acceleration. F equals to ma. 18. Mass was 72 times A. So 18 divided by 72 is 0.25 meters per second square. Now we got the acceleration. What should be the best equation? V equals to U plus AT. 0, 1.4 plus. By the way, acceleration has to be negative. Why? Because it is deceleration, you know, slowing down times t. So 1.4 divided by 0.25. So 5.6 seconds. All right.
Yes,
Now,
sir.
another place in the airport trolley suitcase slope. Cool. A person releases the trolley, moves down the slope. So the component F of the weight of trolley suitcases acts along the slope is 54. Okay, so this is the weight component, right? Is to force. Okay, calculate the speed at y. First of all, we go to find the resultant force. Resultant force has to be 54 minus 18. So that's 36 newtons. And then we got to find the acceleration. 36 equals to 72 times A. So 36 divided by 72, I think 0.5 meters per second square. Now we got the acceleration. Now SUVAT. The distance it covers is 9.5. Initial velocity was 18, I think, 1.4, right? Have they given it?
No, sir, it's
That's
0.
not it. Where is it? Where is
It's
it?
released from rest.
Oh, 0. Final is what we need to find, I guess. Huh? Acceleration is 0.5 and time is not given. 2as equals to v square minus c square. 2 times 0.5 times 9.5 v square minus 0 square. Okay. 2 into 0.5 times 9.5 and divided by answer. So that's 3.1. Okay. Now, calculate the work done by force F. Work done is force times displacement. Force F was 54. Displacement was 9.5. So 513 joules. That should be the answer. And then it says a trolley is released X. Sketch a graph to show the variation of time t work done by F. Movement of trolley from X to Y. Numerical values of work done and T are not required. Okay, that's something, you know. Let me think about it. So force stays constant. However, the speed is increasing. When the speed is increasing, so this force F is responsible, like work is force times displacement. But we don't have the displacement. How sad is that? Let me think about it. It's not fair to give it with time. So how about if we change displacement to ut plus half at square? So s will be the same. This will be 0 because initial velocity was 0. So half at square is the same thing. So s is equal to half at square. So if I replace this f times half at square, so this means that work done and time have a relationship of square. And
Sir,
square,
don't we use 9.5?
no, there's no values are required. We just need to draw a line between work done and time. So I'm trying to find the relationship between them. Okay.
Oh, okay.
So I just got to know that work done has a relationship of t square. A square line, according to math, is a curve with increasing gradient like this. Do you understand?
No, could you explain this
Yes,
again?
sir.
Okay. So Anusha, I got to know, I just thought that I don't have displace. I have to remove this somehow, okay? Because this is constant, doesn't really affect anything. So S is with respect to time, it is ut plus half at squared. There's no other equation, is it? Is it there? So initial velocity was 0. So this means S equals to 0 times time plus half at square. A is also constant. We just found out 0.5. So S will be equal to half at square. Then I plugged it back into this equation. I got to know that work done is force times half times at square if it was like released from rest. Now this is constant, this is constant, this is constant. So it means work is proportional to t squared. Do you understand?
Yeah, but I would have never thought about that in the exam.
You have to think like, you know, if there is time, and this is one of the things you guys need to realize, that they can actually give you any relationship. There's some basic derivations that you need to, you know, think about what to replace there, okay? Okay, so my mind map works like this, okay? Let me tell you. My mind works whenever I know some equation, right? Like work is force times displacement. So first thing I identify what are the constants, right? So I've got to remove them. And then I need to see which two are changing. So because there's displacement being covered like from 0 meters to 9.5 meters. So it means displacement has a relationship with work, okay? Do you understand what I'm saying?
Yeah.
And then I thought, okay, if displacement is related to work. So I thought there are two different equations that connect displacement and time. So one is displacement is equal to velocity into time, and the other is S equals to ut plus half at square, right?
Yeah.
So I thought, why I can't use this equation, because the velocity isn't constant. It was 0 initially and it was some value later. So this is only for constant velocity, so I can't use it. But then I have to use this. And for that, I got to know displacement is proportional to t square, so you can actually replace it there. So you know work is related to t square, okay? Like that. So to move from different angles, okay?
Yeah, that was smart.
Now, the angular slope in B is constant. The friction forces acting on the wheels or moving are also constant. Explain why in practice it is incorrect to assume that the total resistive force opposing the motion of trolley and suitcases is constant as trolley moves from this. This is incorrect because there are two types of frictions. Let me tell you. So there is something called static friction. Okay. Now we don't teach it like this, but it's important to know. And there's something called dynamic friction. Like static friction is the friction we know between two sliding surfaces, right? So it has a constant value. But dynamic friction comes under drag, and drag is as the speed increases, the resistance increases, right? So this means that he said the resistive forces are constant, but they can't be constant because if the velocity is increasing, then the drag is increasing, which means that eventually, all right, it will be so big that it has to go with constant speed. So here I would say that as velocity increases, so does drag, or you can write air resistance. Drag is a general term. In water, it could be water resistance, whatever. So velocity increases, so does air resistance. So it is not constant. Like that. Now, then we go here. So
Sir, could you go back to part 2B, please?
B2. Okay, yes.
Yeah, this one. Don't you subtract the force from the resistive force?
Yes, because the acceleration is dependent on resultant force. Okay.
Yeah.
And resultant force is sum of all forces. So if this is forward, then this has to be negative. So I have to
No, I'm talking
find
about part B.
part B. Where is it?
No,
This
part
is-
B, sorry, part 2.
This one?
B2, no, 2B2.
Acha, 2B2.
Two.
This one.
Yeah, this one.
Why I didn't subtract it? That's what
Yeah.
you're asking. Okay. So it said, what is the work done by F? And F is this.
Okay, fair enough.
All right. Now, the lowest position where its kinetic energy is this. Okay. And momentum is this, horizontal direction. Okay. Starting at stationary at maximum. Fine. We know this already. So the string has a fixed and negligible weight, air resistance, organization. You can draw a solid line to represent the displacement. So where x, it should be a straight line. Like this. Okay. Now, then it says show that the mass of the sphere is this. Okay, that's not bad. 3 marks. No, but very easy. Kinetic energy is equal to momentum over 2m. I bet you guys don't know this, right? 1.27 m equals to 0.2. You guys have forgotten this, but koi baat nahi. I'll tell you. But that's wrong. Oh no. It means this doesn't work. P square over 2m hota hai yaar. Sorry. 0.72 square. 0.72 square. Divided by 2 divided by 0.86. 0.3. 0.30 kg. All right. Now, if you don't remember this relationship, right? It was derived in the notes. You can check back. If you don't remember that, it's like it's no big deal because you can use this alternate method as well. Okay, so you can find velocity 0.86. It's just a bit longer. You don't have the mass, and this is this, right? Now the issue is that momentum is mv, right? So v will be p over m, so we can replace it here. And it will be p over m whole square, and then 0.86 equals to half times m, and the square will cancel, so it will be p square over m. Basically, it will lead you to the same thing, really. So what you do? Now you plug in the values. 0.72 whole square over m, and then m will be 0.30 kg. So it's very important that you remember this. If you have any questions, please let me know.
So we have to know that formula?
Yes.
Really?
So
I've never seen it before.
it is included in our course, Nusha.
It is? Okay, I didn't know that.
How? Kinetic energy is equal to half mv squared, and momentum is mv, right? So what you do? There's the derivation is also included. So you square it. P square equals to m square v square, right? What you do then? V square equals to p square over m square. You replace this with v, right? Right here. Kinetic energy will be equal to half times m p square over m square, which will be half m square and m cancel. P square over m. So kinetic energy is equal to p square over 2m. This derivation is included.
Is this in our notes?
Yes, it is.
Okay, maybe I didn't notice.
Okay. Where is momentum? Maybe I did not do it. Maybe. Let me see. Let me see.
No, it's there.
So is this in the thing you sent? The formula sheet?
Formula sheet. Oh no, this is the derivation relationship. I've done it in the notes. I don't think so.
Okay.
You can
Okay.
check it out. So, but for you, I have done it again, so you can copy this as well.
Yeah.
Should I neatly? You want me to do? So you can actually write. Let me remove this. It's too much clutter. So you can copy this, and you should remember this. Very important. Even in A2, it's going to come a lot. So momentum is equal to mv. Kinetic energy equals to half mv squared. So v is p over m. Now you got to replace this right here. Kinetic energy will be half times m p over m whole square. So kinetic energy now will be half times m times p square over m square. Square cancels out. So kinetic energy is equal to p square over 2m. Okay, write it out, please.
Yeah, thank you.
All right. Now, going to the next question, it says calculate the height h. Do we have the velocity? We don't have the velocity, right? So we can find the velocity. It's not a big deal. So p is equal to mv. or we don't need to do that. Kinetic energy goes to gravitational potential energy. So kinetic energy was 0.86. And this is m times g times h. So 0.86. M is 0.30, I think. Yeah, 9.81 times h.
0.29.
0.29. Okay, thank you. Saves some time. Okay, the distance between point P and the center of sphere is this. Where is point P? First of all, let me see. Okay, all right. So when the sphere is at position Y, the string is an angle. They show that theta is 47. Wow. Now this is a question. Okay, let me see why this question exists. Too bad. That's not fair. This distance, right? This is h, right? This makes it a triangle. But we don't have the horizontal distance. We just have this h. H we found out to be 0.29, right? Well, if I could find this distance, I could do something about it. Can you do, we'll do it, 0.93 minus 0.29? This is 0.64 meters. Okay, so this is 0.64 meters. This is, all right, 0.64 meters. How does it help me? I don't know. Somehow it should help me. I'm trying to find a triangle here, which I cannot. Well, let me think about, this is 6.4, this is 9.3. So, oh, I got it. If this is 6.4, then this is also 0.64. And now I don't need to do anything else. So wait a second, 0.29. So I have this distance and the full one as well. So this angle, no, this is, what is this distance? This is 0.93 as well. Why? Because this is the radius, right? Okay, now I can get it. This is the hypotenuse. This is the base. So cos theta equals to base over hypotenuse. I mean, if like you people do adjacent over hypotenuse. So cos theta adjacent is 0.64, hypotenuse is 0.93. This is a math question. It's not even physics question. That's not fair. Now 0.64 divided by 0.93. So the answer for theta is 47 degrees. All right, you guys have any questions? Please let me know. All right.
Could you go
Now,
back for a second, please?
yes, you can check.
How is that side 0.93?
Because you see, it has moved from this point to this point. So the length of the string stays the same, don't you think so? So Px is equal to Py.
Yeah, that made sense.
Because it is just the string, right? So it will have the same length. That's why. Now it says, for position Y, calculate the moment of weight. Okay. This paper is difficult. Wow. Weight is here. So we have the mass, we do have the mass. So weight is here, and I want to find the perpendicular distance. The perpendicular distance should be from here till here, you know, this distance. Well, I could do that. Perpendicular distance would be sine theta is equal to opposite, which is the distance over hypotenuse, right? So sine theta, which is 47, equals to d over 0.93, which is the hypotenuse, right? So we got the d, right? And we have the weight as well. Okay. Sine 47 equals to d over 0.93. So d is going to be sine 47 times 0.93, 0.68 meters. Now, moment equals to weight, which is 0.30 times 9.81, force times perpendicular distance. Okay. So 0.30 times 9.81. So that would be 2.0 Newton meters. Right. If you have a question, please do let me know. Okay. Now state and explain whether the sphere is the equilibrium and stationary position Y. I don't think so. No. The reason behind it not being in equilibrium is that there is still resultant force acting. Now, I tell you why the resultant force is acting. The thing is that in this, it was in equilibrium, it should stay here forever. Because resultant force, there's no resultant force, the speed must stay constant. If the speed has reached 0 and it's not staying 0, it is going back, it means there has to be some resultant force. Otherwise, it won't change the speed. Okay, that's fine. Now, what kind of forces are acting? That's in A2. All right. For a progressive wave, what is meant by wavelength? Wavelength is the distance between two successive wave fronts. Okay. Now, light from laser has a wavelength of this in vacuum. Calculate the period. Okay, so V is equal to lambda upon T. So this is 3.0 times 10 raised to 8. Lambda is 460 times 10 raised to -9 because it is in nanometers, and we're going to find the period. So 460 divided by this would be equal to 1.5 times 10 raised to power -15 seconds. I think, I don't know. This calculator really sucks. Okay, here. Now, the light from the laser is incident normally on diffraction grating. Describe the diffraction waves at the grating. Now, this is basically just the definition of diffractions. What to do? For 1 mark, you say waves spread when they pass through a narrow slit. You can also write wave spread in geometric shadow. That's the full definition. The diffraction grating is used for different wavelengths of visible light. The angle theta of the 4th order maximum from 0th order central is measured from wavelengths. Okay. Determine an expression in terms of G for the distance between the centers of two adjacent slits in diffraction grating. So we need to find D. Okay, we can do this. So right now we have sine theta and we have this. So the gradient of this line would give me sine theta over lambda. Okay. So our equation is d sine theta equals to n lambda, and d is what we need to find. So it will be n lambda over sine theta, right? N in this is fourth order, so sine theta. Now, interestingly, the gradient g is equal to sine theta over lambda. Here we have lambda over sine theta, so it means it will be 4 over g, like that. Okay. Now, on graph, show this result that would obtain for second order maxima. Second order maxima will have okay. Let me think about it. Because we have d sine theta, so theta is going to technically change because order is different. These are constant, so we have to see if this theta reduces, the angle also reduces. It means for every wavelength, every different wavelength, for different lower order, the angle is going to be lower, but it still be a straight line. So this means that at 4 it will be a lower one, at 700 it will be lower one, but the question is that how much lower? But the thing is, why sine theta does it change like this? This is for fourth order. Sine theta. I think it should be like a straight line like this. But the thing is, there has to be a reason why, where we have to make 400 and 700. You can start 400 from everywhere, but we need to see how much change does it bring. So for that, what I can do is, let's try a trick here. Now, as the lambda is increasing, the gradient should be reducing for the fact, which means that it will be a straight line, but it will have reduced gradient. It should be less gradient than the before one, like this. Is it clear?
Sir, can you please explain again how you found out that the gradient should be reduced?
Yes, I thought that it is a straight line because it conformed to, d sine theta equals to n lambda. So basically, technically, if I make this equation, right, sine theta equals to n lambda over d, right? So this equation, if I separate it like this, n over d times lambda. Now this is Vm times x, right? So this is on y-axis, this is on x-axis. So this is a straight line, and it should start from origin. That's a fact. So straight line, I got it from there. But what I thought really was about the gradient, that the gradient depends on sine theta and lambda. As the lambda is increasing, see, right? So for lower order, it should be below, but then gradient should be like less than before. Do you understand what I'm saying?
Yes, I do. Thank you.
That's how I got to know. All right, so this paper is
Sir, how do
very
you know it's 5 blocks above 700?
5 blocks above.
Yes, 5 small blocks.
Okay. Well, I'll tell you how.
Because there's a mark for it in the mark scheme.
It says you have to drop 5 blocks above.
Yeah.
Interesting. Well, I could have drawn it like this. Would it really matter? No. Yes, I understand why they've said it. They must have said it because I took the middle because I thought if this is 4 and the second order is 2, so this order will be 0, right? So it should be exactly in the middle somewhere. But I didn't think about 5 blocks really. I just made the middle of it. So probably they just want you to like make like this line is like, 4. So probably they want you to make it at the middle of 4. Do you understand? Because it's second order.
Yeah.
You get my point?
Yeah, I do.
Now, Kirchhoff's second law. So it is sum of EMFs equals to sum of potential differences around a closed loop. Okay. Then they have uniform resistance wire, internal resistance, external resistor. Wire XY has a resistance, potential difference across this is given. What is current? Okay. Pretty easy. So I think it should be 1.8 divided by 0.9, 2. Now please write 2.4 and don't write A again. Okay. The number of free electrons at passive point in this. So first of all, I would find charge equals to current into time. So current 45, that has to be 90 coulombs. 1 electron is 1.6 times 10 raised to minus 19. Then how many electrons will be in 90 coulombs? So this will be 90 divided by 1.6 times minus 90. Okay. So this would be 90 divided by 1.6 times 10 raised to power minus 19. Oof. So this is 5.625. Oh, please don't write this. Okay. 5.625 times 10 raised to 20. We should write it as 5.6 times 10 raised to 20 electrons. Okay. Correct is too significant, really. Now it says the resistance R. So EMF equals to IR plus I R1 R2 plus I R5. So the EMF is 4. Where is it? Okay, 4. Current we found out was 2. The first resistor is the wire, which is 0.90. The second resistor is R, and the third resistor is 0.35. All right, so 4 divided by 2 is 2 minus 0.9 plus 0.35. So 1.25 equals to R. So 2 minus 1.25 is 0.75 ohms. Okay, that's pretty simple. Then potentiometer. Oh no. Wait. So this means that it is a null point when this length got to be 0.30, right? So this is what is the total length. Now, the thing is we already have the potential difference of this, right? So we want to find this length xy. So for potentiometer, I told you the equation, right? The equation is voltage xy over voltage xp. So there are 2 points, right? Length of xy over length of xp. So that's the ratio. So voltage in xy is 1 point. Sorry, that it was given somewhere. 1.8. 1.8. Voltage in xp is 1.2. If it shows null, this is the voltage. The length of xy is what we need to find. Length of xp is 0.30. So let's multiply it.
0.45.
0.45. Okay. Thank you. Pretty
Sid,
easy.
could you go back to the previous question, please?
Yes, please. You mean question 4?
No, I got it. Thanks.
Okay. The fixed resistor is replaced by different fixed resistor. The resistance greater than R. Okay. State and explain the change, if any, that must be made to the position P on XY so the galvanometer reads the reading. Okay. If you need to understand this voltage, EMF is being divided into this, and into this hole, right? If this gets higher resistance because V is equal to IR, if the resistance increases, the voltage across this will increase, which means these two will suffer, which means now the voltage across this and voltage across this is going to reduce. Okay, so that's what we know. Now, if the voltage across X and Y, you see, if voltage of X and Y reduces, then you need to move this pointer away or at more length so that it is equal to 1.2. So that's what you should understand. And that's what they're asking. So we say potential difference across X, Y decreases. So we should know this. Hence, the point must move to a greater length such that to increase voltage XP as well. Otherwise, it would not
again,
vary.
please.
Okay, sure. Dekho. Suppose initially, let's suppose this was 1.8, right? This was 1.8. Let's suppose it was reduced to say 1.2. Let's say it was reduced to 1.6. Okay. Suman?
Yes, sir.
Now, if the whole length that we have found is 0.45, is 0.45 meter. So now see, if we apply the ratio, so now this is 1.6. We have to put it equal to, we have to move so that it's equal to 1.2. So length xy was 0.45. So now we want to find xp. So you might see that now the length has to be at least this length to balance it. Do you understand what I'm saying?
Yes, sir.
Now the thing is, why? Because this EMF is 1.2. The only way this galvanometer shows zero reading is when this voltage XP is also 1.2, right? Are you
Yes,
getting
sir.
my? So to make sure this is 1.2, I have to move it further along so that the length increases. With that, the voltage across XP increases so that it balances this. Otherwise, it would not show 0. That's what I've written, okay?
Okay, sir.
Interesting. Okay. Now, question 6. There's no electric field question in this. That's pretty cool. Now, a proton in the nucleus decays to form a neutron and a positive beta. State the name of another electron that's produced. With beta positive, always electron neutrino is released. With beta negative, anti-electron neutrino. State the name of interaction. Weak nuclear force is the one, okay, responsible for any kind of beta particle decay. Okay, then state which of the 3 particles, proton, neutron, beta, have the largest ratio charge. Okay, so what you do? You know, proton has 1 mass, 1 charge. Neutron has 1 mass, 0 charge. Beta particle is 0 mass and plus 1 charge. Okay, so what is he asking about? He's asking about largest ratio charge to mass. Charge to mass means charge over mass. So you can just divide it. For proton, it is going to be 1 divided by 1, 1. For neutron, it will be 0 divided by 1. Sorry. Yeah, 0 divided by 1, 0. And for a beta particle, it is 1 divided by 0, which is approximately infinity, right? It's not actually 0, but there is some value. We're saying infinity. So it has to be beta particle. Like that, okay? Now, so proton is made up of up, up, and down. Up is plus 2 by 3, plus 2 by 3. Down is negative 1 by 3. So when you add them together, it is 3 by 3e, which is basically plus 1e. You just need to show them this, okay? And the quark composition of protons change during decay. State the composition. So basically, when it goes from a positive beta, and you should understand always the up goes to down. It was negative, then down goes to up. Okay. And here's the electric field question. We don't need to do this. Another electric field question. Okay, what is this? Okay, electric field. Not interested. Okay, that's the end. Wow. This was kind of hard. Okay. So you guys have any questions, please let me know. Also, let me check.